Good morning, everyone. Hope you all are fine. Let me introduce myself. I'm Annie Thomas from the Institute of Technology, Durg from Chhattisgarh state. I'm from the country of India. Today's keynote session is on research prospects in the field of machine learning and natural language processing. The two new aspects of AI in the field of natural language processing I want to introduce over here. There is generative AI and explainable AI. So, as we all know about AI, artificial intelligence, everyone knows nowadays, is to make the machine as intelligent as human beings. And with the advent of chat GPT and all are familiar with the term AI nowadays, to make the machine as efficient as humans. So machine learning, that is a part of AI, there is a subset of AI, and in machine learning, we make the system learn according to the knowledge base that is provided. Again, going deeper into that, we have deep learning, that is a subset of machine learning, where we have deep neural networks to have more precise and evaluative results for the problem statements. It has more than one hidden layers, which makes it possible to go deep into the network frames. So depending on all this, we'll go further into generative AI. The machine learning model can be divided into supervised and unsupervised models. Supervised model has a set of labels that are fixed and they are uh, always existing. Like if we get an output also, we will have a label attached to the output from which we can always check whether our prediction is correct or not. The unsupervised models, they are not having a class of labels. We have to predict based on the model that is generated, and maybe that may be unstructured data or unstructured data. So unsupervised learning will be on the basis of the input data that is given. A model will be working on that input data, and it will be having a generated example. Going further into deep learning, we again have two types, discriminative and generative. Discriminative is used to classify, predict, cluster, and it is trained on a data set of labeled data. We already have the labeled data, then the training is easy as we have to put it into one particular class, and it learns the relationship between the data points and the labels. But generative is different, that it generates new data based on the training that is provided to it. So it has to understand the distribution of data and how likely a given example is going to be categorized into that generative example. But in discriminative, we don't have to generate any new data. The best example of generative AI when it came into existence is everyone is having a mobile and we type the text. So when we are typing the text, it will give you, like if I type Villa, it will give the next predicted word as institute, and the next predicted word as of Villa Institute of Technology, Durg. I'll get an option for that because it learns from the patterns I have been doing all these days. So it is predicting the next word in a sentence. That's a best example of a generative AI. Now, if we come to the concept of generative AI, it is also called Gen AI. It is artificial intelligence capable of generating text, images, or other media using the generative models. And if the right side, if whatever I have written, if you can see, not Gen AI when Y input is a number or a discrete or a class or a probability, but it is when it is a natural language text or an image or an audio that shows that it works on unstructured data. So generative AI works on unstructured data to generate new patterns. We have foundation models, large language models, which we'll be discussing in the further slides. So now we understood that generative AI, where we generate new content, and that content may be a text or image or audio. So if we see the category of the supervised, semi-supervised, unsupervised Gen AI, you can have input as training code or labeled data or unlabeled data, and the foundation model works on all this and generates new content, and the output can be a text or image or code or video, audio, anything. So, the main concept here of generative AI is to generate the new content based on the training that is provided. So, here, since I am interested in text, so I have taken only the text input. You can also take image or audio. So, in the so research which we are pursuing here, we are working on text, and that also we are working on the local languages, because in English already the work text to text, if you see the first column, translation, summarization, question answering, grammar correction, all these my research scholars are doing in the for the local languages here, because for English we are having already or much work is being done on this in these areas. I'm not working in image and audio and musicians, but you can, because image generation, text to image, text to video, text to speech, all these are again natural language processing, generative AI can be used in all these areas. We know about the Google's foundation models, that is Palm API for text is a very popular model. BERT we use, VIT for vision we use, VIT, GP2, BLIP, VQA, all these models we are using. Now, when we talk about natural language processing, we talk about large language models. A large language model is specifically designed and trained for natural language processing tasks. What is the characterization of large language models is its large size. So it can be working for vast amounts of text data, or it can be working for other areas also, and it is capable of generating human-like text, understanding context, answering questions. All these things the large language models are doing nowadays. The notable examples are OpenAI's GPT, GPT-3, GPT-4, and ChatGPT and BERT. All these examples are very popular. They train the data, text data, or image, or video, and are capable of generating the new text based on the training data. The large language models are able to handle the large volume of data that is taken from internet or from social media or any other place. This shows some other models which are also popular. Then, after the large language models came into existence, there was an era of transformers. A transformer is a deep learning architecture that relies on the parallel multi-head attention mechanism. The modern transformer, it was proposed in the year 2017, I think, and the paper from which it was introduced was "Attention is all you need." So attention was given to the important data which has to be picked up from the given set of huge databases, and the less attention has to be provided to the data which is not of much importance. On the basis of that, the transformers were working. So a general pre-trained transformer is a more broader term for models based on transformer architecture. With these models, they can be applied to a wide range of problems, not only for natural language tasks, computer vision, speech recognition, reinforcement learning, all the things it is being used. Then these models are pre-trained on large data sets and can be fine-tuned for specific tasks. Some more examples I'll be showing you in the next slide, that is vision transformer, DETR, conformer, swim transformer, perceiver, and perceiver IO. This is what we have talked about generative AI and the concepts which are used in generative AI. Moving on ahead to explainable AI, that is also a new term that is being used in the industry nowadays. And when we talk about explainable AI, it counters the black box tendency of machine learning, where even the AI designers cannot explain why it arrived at a specific decision. Now, what happens is we see the black box design of machine learning, where we have reached to a conclusion, but there needs to be an explanation about how we are getting these results, why it is not like this and why it is like this, and why this explainable AI was needed when we are getting the results. Why was this explainable AI was needed? That was because the domains like medicine, defense, finance, and law, where it is crucial to understand the decisions and build trust in the algorithms. We have made the algorithms, we are employing the algorithms, we are getting the results. Unless and until we have trust in that those models, who we are going to use those models? ChatGPT and Google search are so popular because of the trust we have in those systems, that we are getting such important informations according to the need of the query we are putting there. So, explainable AI came into existence to backtrack, find out how we are getting the results. So, four principles of explainable AI, we have termed these four principles as explanation, meaningful, explanation, accuracy. We are giving an explanation, but that explanation should have the satisfactory level of accuracy. Not that if it is 15% accurate, we cannot say we are having a good explanation. So explanation is there, that is meaningful, that is interpretable, but that explanation should have an accuracy, and the knowledge limit should be so high that explainable AI will be able to provide the system to operate under the conditions for which it was designed, and when it should reach the sufficient confidence in its output. So explainable AI, if we see the advantages of explainable AI, the assisting its users in determining appropriate trust, that's the first part, trust we develop in the system, in the model which we are generating. And the second part is we have an interpretability and explainability mechanism which can explain to the users how it is working. So the next part is that although it is having so many advantages, there are so many disadvantages or issues, challenges which are existing with this. One is contrasting the interpretability and accuracy. We know when we have to reach the human accuracy levels, sometimes the explainable AI may not be able to give the correct explanations. It may be contrasting with the human explanations, and those cases which has to be dealt in the model has to be improved like that. So still it exists, these issues exist. Describing the abilities as opposed to describing the decisions. And there should be the use of abstractions to clarify the explanations. Now, based on this explainable AI, XAI it is also called, we see there is categorization based on agnosticity, that is model agnostic or it is model specific. If it is applied to all the model types, then it is called model agnostic. And if it can be applied to only particular specific model types for which particular task it is being made, then it is model specific. That is the categorization of agnosticity. And depending on the scope, we have global explanation or local explanation. If you want some part or the prediction of some particular area only to be displayed, it will say it is local explanation. And if we want the explanation of the whole model, how it is working, then we go for global explanation. But local explanations are also important because individual predictions are also taken into account in XAI, because global explanation can be given on a larger scale, but local explanation need to go deeper into the problem. So that is again an area where the research can be done, and the different problems can have different perspectives, different aspects to include either model agnostic, model specific, or global or local explanation. So as I told you, we are working on local languages, and on the basis of these local languages, we are doing text summarization. So again, now for the persons who are hearing me, those who want to do and research in the field of natural language processing, machine learning, you can go for single document summarization, you can go for multi-document summarization, you can take any of the languages on which work has not been done, you can go for indicative, informative, evaluative summarization. Any of the tasks can be taken upon, and then on the basis of this, you can generate models, generative models or discriminative models, which will help you to give a proper text summarization. And on the basis of target audience, there is a generic summarization and there is a query focused summarization. On the basis of type of summarizer, you have monolingual, multilingual, cross-lingual, all types of summarization. So I have only included these slides so that if you have some have interest in generic summarization, some in multilingual, so you can pursue your area of interest. Then the two main concepts that come over here is extractive and abstractive. In extractive summarization, the parts of the original text are taken to form the summary, like if we are taking a document and from that document we want to summarize it, the important sentences will be taken out and given as the extractive summarization. But in the abstractive summarization, you need to generate the new text depending on the extracted important parts of the documents. So all this has to be done, which shows that abstractive summarization needs more fields which have to be covered so that the abstractive summarization finds out the meaning and again generates the new text based on the training data. Some comparative studies of year-wise publications has been done. The new concept which has been included for the new language has been done in using these steps. From the input, pre-processing has been done. On the pre-processing part, text cleaning was done, stop word removal based on the local language was done, then feature extraction, and then optimization was applied to find the text summary. On the basis of some of the models, BiLSTM was applied, BERT was applied, GPT was applied, and we could find that the results are, we could compare the models on the basis of the results, and a new model, innovative models are being generated by the research scholars in this area. Then next topic was spelling and correction. So if we can go for two types of grammatically text can be corrected or spelling can be corrected. That again leads to two different. We are working on spell checkers only for that particular language. Maybe in the future we'll be working on grammatical checking of the sentences as well. So we know we have in English we have so good systems when we type a word and if it is wrong it gives the suggestions, and also many systems are already existing imbibed into all the particular softwares. But for the local languages still we don't have the systems like which finds the text errors, maybe the typographic, maybe the syntactic, maybe the discourse error, non-word errors, real word errors, phonological errors, transformation errors, deletion errors, insertion errors, or substitution. All these are the type of errors which exist in the text errors. And you can work on any of this type to remove all such type of errors, being on the domain or outside the domain. Then another system was to classify the newswire articles into the predefined classes of the newspapers so that whenever we get an article, it will automatically be sent to the national, international, business, sports, entertainment, health, or weather. And this has been done on our national language, that is Hindi. For this, we have made the different categorizations, labels, and the discriminative models are being prepared to classify the newswire articles into proper particular label sections so that the newspaper can automatically be aligned to the pages according to what they are. So for challenging task was because of the every language is a challenging for processing for every language is a challenging task because it has different types of consonants, vowels, combinations, and maybe patterns also are different. Sentence structures are different. So from different data set, uh, huge amount of data has been collected and work has been done on this. I'm not able to show you the particular results of these models, but I'd like to tell you that the news wire articles, they will be classified into predefined labels. Another work that is going on is semantic analysis of the reviews which are collected from the social media, and based on those reviews the sentiment analysis where the sentiment analysis models have still not been applied on, and based on that suggestion mining techniques are being proposed so that they give more accuracy than the existing semantic analysis models. So that's all from my side. Thank you for the patient hearing. Thanks.